Good morning, everyone. Thank you for coming. I know it's very, very early, so I do appreciate that you managed to arrive on time. So let's get started. This is the talk on COM, on using modern COM on Windows. It's part 1 of N of a series of talks I plan to give on this topic because, as you might imagine, this is quite a large topic to cover. There are many aspects that we should analyze, many historical tidbits that influence the design of COM and its usage nowadays. And a lot of things have happened in the past years, and there's definitely enough material to cover that won't fit in the typical 1-hour format. So depending on how well it goes and the interest I see and the feedback I get, I plan to cover even more topics that are related to modern COM. So why COM? Why are we talking about COM? Why is this important? Have we really exhausted the important topics to cover at the C++ conference? Well, I think COM is an important thing. And I need to tell you a little bit about my background. I've been working with COM for almost 15 years now. So I work on an application that is tightly integrated with the operating system. Is the Windows application. Advanced Installer is an IDE and a toolchain that helps developers package and deploy their applications on Windows, and at the same time it offers tools and utilities to sysadmins to package, repackage applications, provisioning operating systems at scale, and deliver updates for applications in enterprises. So, as you might imagine, a tight integration with the operating system and with the Windows subsystems is required in order to achieve all these configuration tasks. So, this is why I've been working on Advanced Installer for 14 years now, and I've been knee-deep in COM all this time, because that's where you need to be. And I've hit a lot of issues over time. I've seen the benefits of using APIs that are based around COM. I've encountered problems. I've built utilities over time. My team has built quite a collection of utilities and classes and wrappers around COM. And we've seen the platform evolve over time, and we've managed to adapt and incorporate all the new stuff that we were able to leverage. So just to gauge a little bit of the audience, how many of you have used COM? Oh, okay. So at least I have the right crowd. In the last year, may I dare ask? No? Okay, a few people. So let's start using COM. So how would you start using COM? Well, of course, you need to start here with co-initialize. That's pretty much mandatory. And co-initialize X is initializes the COM library on the calling thread. And this is the important part, the thread. Because nowadays, every application is multi-threading in some way. And it says a thread concurrency model. If requested, it creates a required department, if that's the model that's requested, and initializes the COM on a thread before calling any COM APIs. So this, if we're attempting to call any COM APIs without doing this initialization properly, on each thread of the application, the COM API will fail. And co-initialize X must be called once on each thread that uses COM, and multiple calls to co-initialize X by the same thread are allowed, but subsequent calls will return as false. So we need to balance these calls, and we need to do proper cleanup to make sure that we unload COM if we're not longer using it. So to close COM gracefully, each call must be balanced by co-uninitialize. So You have to be careful, like any API, you have to use it in contract, you have to respect its requirements and make sure that you're using it properly, because otherwise, in some scenarios, it might work, and as soon as you change and leverage some other APIs or refactor your code, you might end up with surprises or unexpected behavior. But before we go on, as you might have guessed by the title of the talk, this has a theme. This presentation has a theme, and it's not just calm. Any Trekkies in the room? Okay, sorry about that. This might be unpleasant to you, but let's power through. I'll have a lot of Star Wars quotes. So, how can we fix co-initialize X? Of course, like any good C++ programmer, this is not exactly modern C++ here, but it's our loved C++ idiom, RAII. We can build an RAII wrapper for com-initialize X. This is a simplified version to fit the slide, but as you can see, we properly initialize and check the return code, and remember if this instance was the one that initialized it on the current thread, and we were able to do the proper cleanup and balancing the calls when this object is no longer needed. So how would we go about using such an object? For example, we can use it on a function stack, and when we have the need to use some COM APIs, maybe something that's temporary, and we'll just initialize this object, request the threading model that we want, and just use the APIs. When we're done, we can the object does the cleanup or automatically. And you can nest as many as these as you need. You can have nested scope blocks. You can have other functions being called on this stack frame that might in turn use COM APIs and do such an initialization in their turn, and everything nests properly and it's unwind correctly. Or you can use it within a whole functional object, for example, a whole class needing COM functionality, and you can tie the lifetimes of the initialization of the COM with the class itself and do proper initialization and cleanup on it. So what do we gain with this simple wrapper? Well, we don't have to care about the thread we're on. We don't have to care if we're already initialized. We can sprinkle as many of these objects as we want. We can nest them, of course, and we don't have to worry about any cleanup. Pretty simple and straightforward, but that was just to warm up and get started. And as I told you in the beginning, I'm not able to cover anything or everything about COM that I might want to cover in a session, so I have to choose. One of the earliest feedbacks I got on this talk was to focus on a topic, so I plan to chunk things up. And of course, I'm going to pick on strings because, well, it's easy to pick on strings, lots of issues there, and it's such a primitive functionality in COM and interoperating with your application code that it's definitely something that we cannot ignore. And although it's a simple thing, there are several issues and painful points interacting with COM strings. So what is the COM string type? Anybody? Vict0r, yeah, our old friend, our very old friend. So COM is a very old technology. It's 25 years old, and some of the design things have historical reasons, and some of the design decisions do show up, and in some parts it shows its age, and some of the design decisions I think are great and are still a valid design choice even today. And COM is the foundation of modern Windows today as well. So we have good parts and not so good parts. So let's talk about some of the oldest parts of COM here, bstring. So bstring is a weird creature. It's a string that basically we have the type definition over there. It's an all HR. And basically is a Unicode code set of characters that may contain embedded null characters that may be null terminated, but it has a length prefix. And because of this length prefix and historical requirements, bstring pointer actually points to the character array within the structure. And basically, every operation knows to read the length prefix and skip it. So when we're adjusting this buffer. So if we would have some very trivial code like this, for example, we want to initialize a bstring with a string literal, and this code compiles links, but it's incorrect. And you would say, I would never write such a thing. But if you do pass a string literal or a macro definition to a function that takes a bstring as a parameter, this might easily happen. And this function will work unexpectedly, or will not work. What we need to do, we need to invoke special APIs to deal with these kinds of things, sysalloc string, for example. And when we finished using it, we need to free this resource because it's a resource that we need to manage manually. So these things go out of control pretty quickly, beyond simple MSDN examples. And we need something to fix this. And of course, again, our old friend, RIIA for the win. There are some utilities in the box. You don't have to build everything yourself, like we did with com_initializex. There are utilities in there. For example, Visual C++ compiler com_support library. That is a non-standard library. You find it in the com_util header. It provides RAII support classes for dealing with bstrings, with variants, with com pointers, and with com errors. All these types behave in the same way. There are special types for working with com that have special APIs for dealing with them, for initializing them, for checking their types at runtime, and for extracting values from them. So these helper classes are C++ classes that implement the simple RAI pattern and make dealing with such resources much more fluid or intuitive. How would this look like for bstring? Well, we encapsulate the bstring type and manages resource allocation through the APIs that we already saw, of course. And it uses underneath reference counting to avoid unnecessary copies. And it does copy on write, which is not an optimization, a good optimization, but misses some other opportunities for modern C++ programming, like move semantics, for example. We'll see later on a little improvement on this section. So copy on write is good. Provides the various conversion constructors from character pointers, both wide and narrow, and from raw bstrings, of course, that some APIs might return back to you. Has all the expected operations like assignment and compare functions and lexicographic compare and so on. So we would use it something like this, pass it through com API, for example, but we do need to be explicit by calling the member function getBstring if we want the raw pointer to the bstring within. The other way around, if we want to construct a standard string from Vict0r, we already have an operator that gives us the pointer to a plain white character array. So we can construct a standard string with assuming a null terminated string there, of course. That's not always the case, but in most com APIs nowadays, we can assume a null terminated string. Also, of course, you can have somewhat intuitive usage there by invoking the expected operations on strings. For example, here, if we want to compare the strings, we don't compare actual pointers, we compare the strings buffers underneath. So it's a deep compare. If we're talking about another utility in there, in that comutil header, there's one for pointers. I'm not going to dwell too much on pointers in this talk because I have a lot of things to cover just with strings. But for pointers, we have a specialized macro that builds a specialized type of com pointer for a required interface. For example, here, if I have an interface that I require to interact with, I can get a new type that is with this suffix ptr, but by just declaring this com type, it is macro, and I can use this type as if it were a built-in smart pointer type and use it with com APIs to get a value back and pass it around and invoke all the expected operators on that pointer type. So somewhat intuitive usage. I think we can live with that macro. It's not such a big deal. And you have to define it for each interface that you need to interact with from an object. Another interesting part of COM, the Atl library. Anybody familiar with it? Okay, a few people. So this is one of the interesting parts of the library. And as the base of all the APIs in this library is the ccom object. All the objects are prefixed with an extra C there, just some old bad habits, I guess. So at the base of the hierarchy, we have ccom object, and everything is built on top of it. And ccom object would look something like this if we want to use it. For example, here we want to create an instance of a particular com class that is provided by us in some module, for example. And we need to call, let's say, set radius API from this object that we created an instance of. And of course, we have to do all the right dance moves there, like holding on to the reference and do all the reference counting things. And this would be the client calling side, the usage of this API that we've built and exposed through a COM interface, maybe. But on the other side, if we need to author such an API or such a COM component and provide it to clients, we would need to write a lot of boilerplate just to get things initialized and moving and declaring the proper interface and bindings for this class. So as you can see, you don't have to read through the whole thing, just see that. And I have actually omitted some stuff. And this is the other part. So we still need to write some more things. And this is the actual code that we actually need to write. So these will be the methods that we actually need to expose, the actual important functionality. And as you can see, it's very, let's say we use some templates, or we find a way to synthesize all these class parts, or somehow generate all this boilerplate, but it actually makes us, it makes it very difficult to actually follow the code and actually see what we need to see in such a messy class, or such a busy class, or such a busy header for that matter. So you quickly lose focus on what's important in that functionality. But in terms of usage and the patterns used there, if we examine ccom object and see its format or definition, we do encounter a popular pattern even today. Does anybody recognize this pattern? Exactly, the curiously recurring template pattern. So we have a tradition with bad naming in C++. So but this is the pattern indeed. And it's heavily used in the Atl library and WTL library, which is an extension of Atl. And it's still used today in application code, and even in modern C++, it has a place in various idiomatic usages. It achieves a similar effect to the use of virtual functions, but without the cost of dynamic polymorphism. So this pattern doesn't require a vtable for classes. And this was the weapon of choice 25 years ago because of performance reasons. Back then, virtual functions were a thing, so they were considered very expensive. And of course, binding is done at compile time. So this pattern is heavily used. If you're using ATL, it's impossible to ignore this pattern. It gives us unlimited power, but at a cost. We have to deal with templates. We have to write inline code. And it gives us flexibility. So that's the thing we're gaining here. If we examine ATL in parallel with the other utilities we received using the comutil functionality. So if we're looking at ATL, we have a correspondence. So like everything good, we have to reinvent the wheel. For CCOM-PTR, we have CCOM-PTR in ATL. We have a CCOM-BString class, and we have a CCOM variant class. So how do these fare up against the other helpers that we got? For CCOM-BString, again, is the ATL wrapper for BString primitive. It manages resource allocation through the same APIs, so nothing new here. But this one supports move semantics in newer versions of the Atl library. So, of course, this was not available back then. But in, I think, the last 7 or 8 years of the Atl library, so the latest versions do support move semantics. And this is actually a very good thing because this class doesn't implement copy on write. So we do need this badly. It provides, again, the various conversion constructors. It's not on par with the CCOM, with the BString T type, but it's very similar. All the expected conversions, all the expected operators, and simple usage would be something like this. Again, here a small difference. We do have the operator Vict0r that automatically gives us the conversion to the underlying type without being explicit, with like we had to be with BString type, where we called the getVict0r function. The other way around, constructing a standard string from CCOM BString type, it's automatically done. We have the conversion operator there. Also, like we did before, we can have a somewhat intuitive usage and do string comparisons, fairly trivial. But, like always, this is not enough. We have to try again. So we have a new kid on the block. And when I say new, I don't mean it's fresh. So this would be C-string, and this would be its definition. It's a template class. And it supports both narrow and wide characters through the string traits policy. This is, of course, for dealing with APIs that were before the Windows NT family of operating systems, like Windows 98, for example. And it manages resource allocation and deallocation. Again, nothing new here. It uses reference counting to avoid excessive copies. So it uses copy on write again. This is an older implementation. It does not have move semantics. It does copy on write. It has a lot of utilities and methods. So this is a very rich class, and it's a very easy to use class, and has all the required conversion constructors and operators and utility methods and string algorithms even for tokenizing and parsing strings and formatting strings and extracting string ranges and everything. So it has functions like find, make lower, reverse, tokenize, trim, and all the things that we would expect from a good behaving string class there. And typical usage would be something like this. If we want to get an underlying only BString type, we would need to be explicit and use this API, alloc C string. And this is a gotcha because you don't get the underlying type, the underlying string type. It's not a bstr. So we need to be careful here, because if we do require a bstring for interacting with the COM API here, we do need to allocate a new OLE bstring type, and we do need to manage that manually. But if we want to round trip between a standard string and a C string, this makes things easier. And again, usage might look something like this, not very painful. We need to be a little explicit there with using the underlying buffer of the standard string. But we get all the operations. The only catch I might point out here is the alloc string there. So but that's rarely required, I think. But what about modern COM? So I keep hearing that things have improved over the last 25 years. And what have we gained in modern COM? Well, we have this thing, is the Windows Runtime, or WinRT for short. This is a system submodule that only on Windows 8 and Windows 10 and newer operating systems or newer versions of Windows 10. So this is not available in older operating systems, and if you're targeting an older, like Windows XP or something older, you cannot leverage this. But if you're constraining yourself to modern targets, this is a fresh option. And let's see how it fares out in this evolution of COM. Well, Windows Runtime is a modern class-based object-oriented Windows API. It uses metadata to learn about classes and members, and it has a rich type definition, description, and understands the objects it interacts with. It offers language projections for natural familiar use in your preferred language on the Windows platform, of course. And it has bindings for C++, C#, JavaScript, and several others. How do I access the Windows Runtime? Well, again, this runtime evolved somewhat in the open, so we have gradual support and various ways to interact with it from when it first appeared in Windows 8 and what was available back then, and newer facilities that were provided by Microsoft to make it easier to interact with it. So we'll take, again, a short historical path there. And the first step at it was the WRL, or WRL, like some people like to call it. And this is a very thin template wrapper. It enables you to easily implement and consume COM components. Adds very little abstraction over the raw runtime APIs. It was very quick to bootstrap and get it started and get people using it. And Microsoft internally consumed the Windows Runtime in this way when they got started, before they got any compiler support. It gives the ability to control the underlying code, so you can mess with basically anything underneath. So it's all out in the open. They're just very thin wrappers. And of course, error handling is based on H result, so no fancy mechanisms for dealing with errors there. And it's, of course, this design is inspired by the ATL, so it can mix naturally with old COM code. So if you have an existing code base, you can naturally mix them up and use ATL with WRL, and it makes activation of COM objects easier. So you get rid of some boilerplate that was required in the past, but at the same time, it gives you access under the hood, and you can pretty much get started quickly. The good thing is that it used ISO standard C++, so there were no custom extensions there. And of course, it has all the utilities like smart pointers and RAI wrappers in its site. But it's still rather verbose, more code than we would like to write. Yeah, of course, it was the first wrapper library that supported developing universal Windows applications. Next next attempt of interacting with this API was the C++ CX extensions. So this was the Windows Runtime C++ template library. So it uses a non-standard C++ language extension. So this is when Microsoft implemented an extension in their compiler, and Visual Studio offered you the possibility to write and interact with these APIs directly and with a very terse syntax. It has some learning curve because it's a new thing. It's language extensions, so you do need to learn them. It offers a high-level abstraction, which is the good part. And it represents H-results error codes as exceptions in the system, so you can easily handle API error codes there. And of course, almost no boilerplate there. So it automates every housekeeping task like memory management and string management and initialization and teardown and everything. So, but it's discontinued. So it was a good crutch, good way to start. But the fact that it used a non-standard C++ made it very difficult for people to interact with it and mix this kind of code with portable code, and that made it a little more difficult to adopt. But it was a good crutch to start with. Let's see some examples. If we would need to use world, we would include Windows Foundation and the world wrappers. Those are the headers, basically, to get started. And some of the namespaces for the foundational stuff. And for example, if we needed to initialize COM, now we have a wrapper in the box, so we don't need to implement it ourselves. We have row initialize wrapper to initialize COM. Pretty straightforward and very similar with what we saw in the beginning of the talk. And if we want to use a class, we get an activation factory, and it's relatively easy to get an instance of an COM class through one of its interfaces there. A very simple example, fairly verbose, but at least it's standard C++. What about a string type? What's the underlying string type for the Windows runtime? Anybody care to venture a guess? It's not bstring. It's something new. It's hstring. So hstring represents an immutable string in a Windows runtime. So it's basically like a handle. Its usage is through APIs such as these ones, Windows create string, Windows duplicate string, concat, delete. Again, fairly explicit, verbose. We need to manage this as an opaque resource. But at least it points to an immutable string, so that simplifies things. And APIs look like this. Some signatures to get a feel for it. Again, not my favorite kind of API, so I'm not very happy when I see these kinds of APIs. I've dealt with things like this for way too many years. And again, if we're using WRL, for example, we can set an H string like this. And let's see if we can be more succinct about it. For example, if we're using the language projection of the platform string on C++ CX, typical usage would be something like this. And you might notice a weird character there. That's a non-standard extension for C++. They call it the hat, because it looks funny. And that represents a smart pointer, basically. So typical API would look something like this. String hat and string hat, for example, for concatenating strings and for testing lexicographic equality. So we have to deal with non-standard extensions and special rules and understanding their behavior. So people used to do this. Nowadays, it's deprecated as a means to interact with the Windows runtime. So we have to move forward. And the way forward is through something like C++ WinRT. So what is C++ WinRT? It's an ISO standard C++ 17 language projection for the Windows runtime. So no more custom extensions for the C++ language. It's a header-only library, so it's easy to get started with. It has C++ class wrappers for WinRT APIs, and you can both author and consume Windows runtime APIs with it. Of course, it supersedes all the previous attempts to interact with the Windows runtime, so those are deprecated from now, but it's a good learning opportunity to know how it used to be. And its development was in open source, and it was available on GitHub. Nowadays, it's included in the Windows 10 SDK, starting with version 1803. It's built in the SDK, so you don't have to pull it from the repo. And this is the current way of interacting with the Windows runtime and the recommended way of dealing with it. So there are lots of materials and documentation on it, and it's right there in the box. So it's a project that was started by Kenny Kerr, and again, I think there's a lot of learning opportunity here for us as developers to study it and see how it evolved and what problems it tried to solve in general, and the approach it took in using standard C++ and some tools to deal with metadata, because COM objects need to be formally described in a language that can offer projections in any language that we would need to interact with them. So it's not enough to say, oh, I'm going to build this component and offer some C API for it, or C++ API for it, and that's it. If we want to describe the types with the proper metadata to expose it and to be able to consume it from any language that we want, we do need to properly describe its interface and its layout through a special language there. So Kenny built some very nice tools to parse and extract that metadata and actually synthesize standard C++ class definitions for the underlying WinRT objects. So if you want to learn more, and I do encourage you to watch this talk when you have the time, again, I think even for people that are not interested in COM per se, there's a good learning opportunity there to see some very interesting techniques and tools that you might need to build in the future as well. So another presentation, more recent one, by Brent Rector and Kenny Kerr from the Build conference, again on effective WinRT usage and using COM APIs. Like I said, it's in the box, so if you're using Visual Studio 2017, in a fairly recent version, 15.7, you have this library right in the Windows SDK. So if you're installing the SDK, you get it for free. If you need further support, and you need, for example, debug visualization for projected types in your favorite language, for example, let's say you want debug visualization in C++, something on par with what we get for C# debugging. This is an extension that Microsoft provides in the Visual Studio Marketplace, and it's free and one click away to install. It gives you also project templates to get started and create a new application from scratch. And of course, it has targets for MS Build support and C++ WinRT projects, projection headers and components. And I think this is almost a required component to have on your Visual Studio box. So again, let's see some usage. How is C++ WinRT going to make my life better? We have some pragma directives there to link with the appropriate library, the headers that we need for the Windows Foundation and the base library headers, and the required namespaces. And to get started, something similar to what we saw with our co-initialize.x, but this does a little bit more. We have the winrt init apartment method. Again, this is standard C++. You can compile it with any compiler that you want. So there's nothing custom, no specific language extensions or anything. So it performs better, produces smaller binaries than any other language projection because it's a very thin wrapper. And it outperforms handwritten code using the API interfaces directly, like WRL, because with WRL or older techniques, you might get some code bloat because of the way the code gen happens during compilation. So the underlying abstractions use modern C++ idioms that the Visual Studio compiler understands and can optimize pretty well. So it doesn't have to generate code on the fly and synthesize things. So it's a very, very, very efficient library and very thin. Again, what's the underlying C++ Winrt string type? Let me see. Can you guess again? It's not Vict0r. It's not hstring. Not, at least not the previous one.
Standard string.
No, it would be nice, but no. Life's not that easy. Maybe next year I'll talk about that in a new library. No, it's winrt hstring. Be aware this is a different type. So it's a wrapper. Again, this is a C++ class, so standard C++ here. And again, it's an immutable string because this is how the Windows runtime sees strings. And typical usage would be something like this, initializing from string literal. It encapsulates the platform hstring. Notice the difference. This is in all caps. So this is the platform abstractions from the Windows runtime, the raw primitive. And the winrt hstring class, lowercase hstring, can construct from a string view, from a pointer to characters, and a length, and all the expected construction and conversion methods there. So we'll talk about string view in a bit. So it makes our lives a little bit better. Some typical usage here, for example, we have some method there. We can default construct it, we can copy construct it, we can construct it with a literal, with a pointer length, all the things you might expect, or a string view, for that matter. Has an operator that gives us a string view on the underlying string type. For example, if we would need to interact with some platform URA class there, we can use it with a string literal there directly. We can get a standard string out automatically from an API, for example, from the domain API that would return something like a winrt hstring, and through automatic conversion with string view there, we get indirect conversion to standard string there. So as you can see, the domain API doesn't return a standard string, but we get that glue code, which is the string view, which gives us a gateway to standard strings. So it's almost like we would deal with standard string, but not quite. An hstring is a range, so you can use range-based for loop or for each algorithms, just like you would with standard string. For example, if you wanted to iterate characters in there. winrt hstring is UTF-16. It shouldn't surprise us because this is how the Windows operating system deals with APIs. So all APIs in Windows are UTF-16. But it plays nice with UTF-8 text. So you can have all the expected conversions there, widening conversions or narrowing conversions. And if we're talking about strings, of course, this is something that we might see in our projects, a myriad of string types that we need to interact with We have our old friend B string there, Atl string, pointer to characters, standard string, and many others. So this makes our lives complicated. And if we want to simplify things, we have to deal with scenarios like this, where we have to deal with that platform-specific, let's call it X string, X being a placeholder there for all the previous ones. So if we have to interact with the platform there, but we have the application logic and our models that use portable code and standard C++ code that uses standard string, we have to round trip and have some glue code that makes it possible to interop and do the required data marshalling between those APIs and our object and our business logic. So we do have to deal with some glue code, and it all works fine because, yeah, you get some duplication, and you may make some unnecessary copies around the way when you round trip string data between the two formats. So it might be inefficient, and it even might be a little ugly in methods that mix the two types together. So you have the separation, but you would have the glue code that looks funky. But it doesn't scale well as soon as you start to build up and accumulate string algorithms in your applications and utilities. What do you do then? Do you restrict yourself to implementing those utilities and helpers just with standard string and not being able to leverage them and use them with your platform-specific strings? Or do you use a common denominator technique, like implementing everything on top of pointer to characters, and you lose all the type safety and the power of the type system and being able to work with smart objects? So this is a tough issue. There is a helper there for us. It's string view. It has its gotchas, and I do have a whole talk just on string view and how it tries to help with this interop issue and how it behaves like a proper glue code between these two worlds. But it does come with some gotchas and pitfalls, and people need to be educated and be able to use it properly without any surprises there. But it's a big helper. Yeah, is the C++ string view answer to our questions here? Maybe, but we need to know a little bit more about it. So it's a thin wrapper. Underneath it has a pointer to a buffer and a length, and its main purpose is to serve as glue code in overload sets. It does not manage the storage it refers to, and the lifetime is left to the caller, and it is a wrapper to an immutable sequence of characters. So you see the correlation or the relationship it has with the WinRT string. So it feels like a natural fit here. It has the expected constructors and conversion operators there. It can be automatically converts to a string and a string view. It has all the intuitive operations that you might expect, but it has its gotchas. Its design, of course, is to avoid temporary copies, like I said before, and it interoperates pretty well with the standard string. I would say almost too well. This is where the gotchas come from, because it's very eager to convert back and forward, and it has some complexity in usage. So be aware. I do recommend that it's a very attractive type, and it's something that's of immediate benefit when used right. But you do need to educate yourself so that you don't fall in the traps. So I do recommend that you read the required articles on that. So back to COM. So Windows COM is 25 years old. Of course, this shows in many corners. I claim that it's more relevant today than it was in the past. Microsoft has made a big bet on COM. It's a good technology underneath, but it has evolved. It has its quirks. The modern Windows operating systems, Windows 10 and all newer versions, will be on top of COM, but the way you interact with it will change over time. And you need to stay on top of it if you want to make your lives easier. So with the advent of modern C++, COM objects can be used easily, and leveraging libraries like the CPP WinRT make the experience feel totally new. Even though we're interacting with very old components and very old designs, our way of interacting with it feels fresh. So I would claim the dark side of COM is the pathway to many abilities some consider to be unnatural, but I think it's something that we can manage. And because I do have the time, I want to show you just one more thing. This is very, very fresh. So, I mean, really fresh. And that is Xlang. Anybody heard of it? No? Yeah, I get the chance to preview this. So Xlang is a cross-language, cross-compiler, cross-platform generalization of WinRT. Again, my personal hero, Kenny Kerr, saves our butt here. And if you want to read more, there's a blog post by Kenny there. As you can see, it's from October this year. And this is a very promising endeavor, very, very promising project, and I'm on the edge of my seat, literally trying to see how this project evolves, and I'm actually very anxious to the next Microsoft Build conference, and because I hope Kenny will make a presentation on the evolution of this project and especially on its roadmap. So what is this? So for example, if we already have a shared library that is written in some language A and is running on some operating system, not just Windows 10, so it might be Windows 7 or Linux or some Apple operating system there. So if we have a shared library written in some language and we want to expose the API of that library to another application that is written in a different language and is able to run on that platform, Xlang provides a language projection from language A to language B on a platform that is supported. So this is definitely not COM. This is something that is neutral, so it's not something that's tied to COM directly, but it's something very similar to what CPP WinRT does today. So this is a generalization of the techniques used in CPP WinRT and the techniques of describing object metadata and providing language projections from one language to another. So this is something that's very exciting to me, at least. And I see this as a potential usage outside COM in many applications that need to offer this type of interop. So the project is open source. It's developed in the open. It's not something that's cooked on closed doors. Be aware, this is work in progress, so it's highly experimental. It's far from being production ready. But it's something that you can follow on. It's on GitHub. There's the link. You can dive in and see the progress and see what's there. It actually uses a solid metadata reader that Kenny has written for CPP WinRT. That reader is fairly mature and well developed and tested because it is used in CPP WinRT as well. So, of course, it's old standard C++ there. It's incredibly fast, and it's a portable abstraction. It implements this ECMA 335 format to describe metadata. And its goal is to reach feature parity with CPP WinRT in what it can do to describe types. It's still not there yet, but it has a lot of promise, I think. And be aware that the Xlang project is not a port of the Windows runtime or COM on other operating systems, so don't think it's a way of porting COM APIs to other operating systems. It's not that. And it will not port the WinRT APIs to other operating systems. So it's not a method of backporting WinRT to Windows 7, for example, or to Windows XP. So don't fall on that trap. So it's a way of offering agnostic language projections on different operating systems. So it is something that I see as being very cool, and I see a lot of potential in applying it in various other ways, not just for COM or WinRT. So with that, I am almost done with my presentation, and this is why I think COM has changed in making our lives easier and interacting with the operating system. And I think even if we're not interacting with the operating system, I think there are lots of learning opportunities in finding out about the new libraries and the new technologies and new idioms used today. So there's lots of learning opportunities from COM there. So thank you. If you have any questions, you can get a mic, or if you can catch me on the hallways later. If you're too shy, the mic is necessary for the online recording. So otherwise, you can, if you're shy to go on record, you can catch me on the hallways later. So there's no problem with that. I'll be here. There's one guy. Yep.
Thank you. It was a useful talk, but for limited crowd, I would say.
Yeah.
I wonder about the future of COM, and so we get this WinRT, but it's also limited use cases. So I wonder where this will be applied, because they have a C#, which is more spread around and also supported on Linux and so forth. And now we have a kind of old COM or WinRT that is, yeah, where is it existing and for what purposes they use it?
So first of all, I cannot speak for Microsoft because I don't work for them, but I'll give you my personal take on it. So as COM evolved, my experience is that we're seeing a slicing of COM. So COM was a great design from 25 years ago. It was a general purpose abstraction of interacting with distributed systems on different architectures and being agnostic of the operating system and everything. So it was a grand design, and it started as a very ambitious project, like an industry-wide project. But over time, it narrowed in focus, and each step of its evolution sliced it, in my opinion, in terms of not every component or not every aspect of the COM design was ported forward with each rinse and repeat cycle or each evolution step. So COM nowadays doesn't try to be the interop technology between operating systems or anything like that. It's the way to interact with Windows, period. So if we're comparing this with things you see, for example, with .NET Core or anything that's ported to other operating systems, I don't think you're going to see anything like this for COM. COM is for interacting with Windows, and that's it. And newer evolutions and newer libraries that make your life easier, it just makes your life easier interacting with newer system APIs or exposes system APIs that are safer to use and easier to use with a more terse syntax or in a more object-oriented way, so to speak. So it's a modernization of the platform. It's not a way of extending the platform or making a platform abstraction layer that it's across, the industry, so to speak. So I don't see it as a way of making it like a lingua franca of interop or anything. So I see it as a narrowing focus. And I don't think it's a bad thing. People interacting with it interact with it for Windows. So my hopes are not in that this will be ported to some other operating system or anything. So I see WinRT as a focus and as a helper for me that I need to interact with the Windows operating system, and it makes my life easier. I don't care of any cross-platform promise there, and I don't think it will get that. And even the Xlang language projection is not meant to be a port. It's meant to be just that, a projection, an abstraction over language and data representation on the same operating system. So although it has ambitions to be on different platforms, for example, let's say on Linux, its purpose is not interop. Its purpose is making a library that's already runs on Linux, interact with an application that already runs on Linux, and make them talk to each other and understand their data types and do the proper data marshalling between them. So from language A to language B, for example. So it's all about metadata. It's not about communication across, it's not a distributed COM kind of thing. Like we used to have DCOM in the past. I think people's enthusiasm towards that died. Okay, I think we're out of time. If we do have any other questions, I'll be on the hallways, just catch me. Thank you.